Hey everyone, thanks a lot for tuning in to my talk at the virtual version of React Europe 2020. As the heading shows, we're going to be learning about React hooks and we'll build an auth-based to-do app in the process. My name is Lukonde Mwila, but a lot of people call me Luke. So you can imagine each time I introduce myself, I do get to hear a lot of Star Wars jokes. I don't know if I would qualify as an avid blogger just yet, but I have a Medium account and regularly try to post technical articles over there. So if you're interested, please go ahead and check it out. I'm a software engineer or software developer if you like, and I work for a company called Intellect Software in South Africa, and I consult at Standard Bank SA. So what can you expect from this presentation? I won't be covering every single hook that there is, but I try to touch on each one of the basic ones and a few that might be considered a little bit advanced. I should say right off the bat that this presentation is actually based on an article that I wrote last year, and I won't be able to delve into as much detail in this presentation because of time constraints. So if there are any gaps that you pick up on, please do have a look at that post and it will certainly be able to patch up any things that you see missing from this presentation. Also, there's a repo for it and you can see it on the left-hand side over there. So go ahead and search, and when you do find it, please go ahead and just clone or fork that and make use of it however you like. Let's go in. I've already created a React application using the Create React App CLI, and I'm using the TypeScript template. In addition to that, I have installed a couple of dependencies, Bootstrap and ReactStrap, just because we don't want to worry too much about styling. There are some presentation components that I've already created, and I'm using styled components for that. Also, down the line, we're going to be using the UUID library to generate unique IDs for each of our to-do items, and we're going to be using Validator to help us with validating the input fields and the forms that we're going to implement. Let's take a look at the folder structure. Inside source directory, I've created components, containers, contexts, custom types, and utils. Components and containers will probably be straightforward, actually contexts too. Custom types is where we're going to have our type definitions that we're going to add. There won't be too many, so you don't have to worry too much about that. And inside of the utils folder, we're going to have some helper functions, and we're also going to have a couple of constants that we'll be using in our application. And this is where our custom hooks are going to live inside utils. Let's start by looking at the index.tsx file. The only change I've made in here is I've imported Bootstrap because we want to apply that styling globally throughout our application. Inside the app component, I'm importing root container. What exactly does that do? Let's go ahead and look at that. So root container isn't really doing anything at the moment. We're just importing one of the presentation components that are created inside our styles, and we're using wrapper over there to wrap around our login component, also living inside containers. I'm going to go ahead and open that. Bare bone right now, nothing to it. And now we're going to look at our components folder. Inside here, we have an error message component. This is just going to be a way of actually handling all of our errors in a consistent type of way. We'll have the same styling for any error messages that get displayed. And last but not least, we've got a styles file over here. And inside here, we have a bunch of presentation components like wrappers and containers, as I'm calling them. Probably best to just stick to calling them wrappers to avoid any confusion. And if you want to delve into this, the best thing would probably be to have a look at the repo so you can look at it in detail. I don't want to spend too much time looking at it because it's not the focus. All right, now that we have that, let's get cracking. An important place to start are the ground rules, and the first one kind of leads into the second one. So when it comes to using React hooks, you must only use them at the top level of your function components. That means we can't initiate or implement these hooks inside nested functions or code blocks like the if statement, for loops, or any form of nesting. They have to appear at the top level in the root level of your function components. Cool. That being said, let's take a look at the first hook that we're going to be delving into, the useState hook. So previously, function components were stateless. We couldn't, were completely stateless. We couldn't implement state in any way. But thankfully, with the introduction of hooks, that has changed. So the useState hook allows us to add state to our function components. And If you look in this slide over here, I've put the syntax that you would use to actually implement this, and it returns a state value. The useState hook returns a state value as well as a function that you can use to update that very state value. And we make use of it using the destructuring assignment syntax, which if you're familiar with JavaScript, then you would probably recognize it. And we're going to use this same pattern with the same syntax with the other hooks as well. And you will notice that as we go along. So let's take a look at how we can actually make use of this in our project. We're back in the login container, and as you can see, I've made a lot of modifications. Previously, all we had was a span element that we were returning with the text login. Now I'm returning a form with two input fields, email and password, as you would expect for sign-in. I'm also making use of a couple of components from the React Strap component library to build out this form. At present, we're not actually submitting anything, so that's something that we'll take a look at later on. What we do want to do is we want to be able to capture any user input and store those particular values in the state. And so to do that, we're making use of the useState hook. As I mentioned, we need to use a destructuring assignment, and that the first item that gets returned is our actual state value, and the second item is used to set the state. And so I've got three state values over here: user email, user password, and loading. And so if we come down and look at these inputs, you'll notice that I'm passing user email as the value prop over here because we want to be able to keep track of that. And more importantly, when the user is updating the field, we want to make use of the setUserEmail, which is the function that actually sets the state based on whatever it is that the user enters in there. And we do the same for the password field. At the moment, we're not making use of the setLoading function, and that's because we haven't yet implemented the actual submission implementation just yet. What we have done, though, is we want to be able to provide some feedback to the user, so when they do click on the submit button, it will indicate that it is currently loading. That will be in the case when we actually update the loading status to true, and it will show them this text. In the case that that isn't happening, it will return sign in. Also, when there is something happening in the background, we'll disable the button so that the user doesn't keep on clicking it. Next up, we're going to look at custom hooks, and this is a great way to share logic across different components, and you'll see exactly what that looks like in our example. I'm going to be creating two custom hooks, one for handling our errors and the other for handling the authentication status of the user. Let's turn our attention to the two custom hooks that we're going to be making use of in this application. The first one I'm calling useAuthHandler, and we're going to be using this to track the authentication status of a user. I start by importing a custom type definition called userAuth, and this is going to shape the kind of object that we'll be expecting. It will have properties ID of type number and email of type string. I've also created a constant that I'm calling default userAuth, and this object has an ID of 0 and an email of an empty string. Our custom hook is a function that is going to expect an initial state pass-through here of type userAuth. And inside our hook, we're also making use of the useState hook. And we're using the destructuring assignment to get an auth object as well as a function that will be updating that object. In addition to that, we have two methods that we're going to be making use of in our custom hook: setAuthStatus and setUnAuthStatus. SetAuthStatus is what we're going to use to get the userAuth object in the case that a user has been authenticated, and to persist that in local storage, as well as add it to state using the setAuth function. SetUnAuthStatus will basically act like a logout or signing out functionality. We'll clear anything in local storage, and we'll also set the auth back to the default userAuth. And so we return an object with these very properties, the auth object and the two methods that we created. And feel free to, if you want to add any additional methods. And when we use the destructuring assignment to make use of this custom hook, we'll have access to these very properties. The error handler hook, or useErrorHandler as I'm actually calling it, Similarly, we'll have an initial state that gets passed through of type string or null. And we're also using the useState hook in here. And this hook is actually going to be used to display any errors that are encountered in the application. I only want to display an error for 3 seconds, so I'm making use of this function over here called showError, which receives a particular error message. And then we use the setError function to set the actual error message based on the value that we get as a parameter. But we also make use of the setTimeout function so that after 3 seconds we set error back to null. And then we return error and showError as the properties that we want to be able to make use of when we use this custom hook. Inside our login container, we'll see how we're actually making use of the useErrorHandler custom hook. Now, you'll notice that I've actually updated this login container and already populated some additional code, and I've done that for the sake of time. I've imported the error message, which is a presentation component, and in the case that an error is actually encountered, then we pass the value for that particular error as a prop, and it will display for 3 seconds. Let's look at how we're actually making use of this custom hook. Inside this auth handler function, which fires or is executed in the case that a login form is actually validated correctly, then we have a try-catch block over here, and in the case that any errors are encountered, we use the showError function, which is one of the properties that we get from our useErrorHandler or our custom hook. Next up, we come to the useContext hook. I absolutely love the context API. It basically allows us to pass and access global state around the component tree without having to pass down props all the time. So any component that is nested inside the context provider can tap into the context and retrieve the state values as well as reference any functions that can act on that state. So we can call the useContext hook to get access to that context. Let's see what this looks like in action. We're back in our code editor. And before we can make use of the context hook, we actually need to have a context. As you can see, I've gone ahead and created one called authContext, and it is living inside of the context folder over here. We'll take a top-down approach to see exactly what's happening in this file before we can tap into the context using the useContext hook. And as usual, we start by importing a couple of dependencies, the userAuth type definition, which you're probably familiar with by now. And then we're making use of the second custom hook that we created, and I'm referring to it as useAuthHandler. You can take a look at the shape over there and see that the exported values are auth, setAuthStatus, and setOnAuthStatus, which is basically working like a logout for us. In addition to that, I've got a couple of utilities. I've got the const over here, which is the default user auth, and this is basically a value with two properties, ID, which you might recall was set to 0, and email was set to an empty string. In addition to that, I've gone ahead and created this function called getStoredUserAuth. I hope the name already gives away what it actually does for us, and it checks to see if there's any user auth in local storage, and in the case that it does exist, then it should return that and parse it, and in the case that it doesn't exist, then we just return the default user auth value. Back to our context. You will notice that there's an interface over here, and I'm basically using that to define the type or shape of our context. And you'll notice that the properties for it are based on the custom hook that we created. So I go ahead and create the context over here, and I'm referring to it as authContext, and I'm exporting that because this is the value that we'll actually be importing inside of a component and that we'll make use of to tap into our context. Not only that, we're also going to need a provider to wrap our component tree structure with. And so I create that down here. I'm referring to it as auth provider, and you'll see that children here is basically what we're going to be using or passing as a prop to insert or inject all the components that this provider is going to be wrapped around. And the value that we're passing through to this provider are the values that we get from our custom hook, useAuthHandler. And what I'm setting as the initial state is the getStoredUserAuth. So in this case, this function will basically return either the actual value from a signed-in user or the default user auth object. And the destructuring assignment here gets us the values that we want, and we pass them through to the provider. I'm going to head over to app.tsx, where we're making use of the auth context provider that we export from that very file. And as you can see here, it is wrapping our entire application, the root container. How does that actually play out, though, when we want to make use of the useContext hook? I've commented out the import over here, and I'm just going to include that. So you can see we're importing the auth context over here. And so to make use of it, we go ahead and create that. We're making use of the destructuring assignment. I'm going to do this, React, that's the wrong spelling, .useContext. And the context that we're using is the one that we're importing, the auth context. And now I should probably get a suggestion when I start typing in here. As you can see, set auth status is one of the values that gets suggested, which is what we actually want and is the one that we'll be making use of. And so, as you'll recall, in our auth handler function, our fake REST API JSON placeholder returns the values ID and email. And these are the values that we actually want to use to set the auth object. And so I'm going to go ahead and do that. ID and email, which meets the contract or the expected type of object that is required when setting the auth status. Next up, we're going to be looking at the useEffect hook. Now, the useEffect hook takes two arguments. The first one is a function that executes after every render, and this function will run when the component mounts as well as when it updates. Also, if you want the same component cleanup functionality that you'd get from the component will unmount, you can return a function inside a useEffect hook. It will use that function to clean up. So what about the second argument? Because I said it takes two arguments, right? You can optionally provide an array of inputs. If so, the effect will only run after renders where the inputs have actually changed. Something that's really important to note is that if you do not provide this second argument, then the function or effect in our first argument will run after every render of the component. Your other option with this second argument is to provide an empty array, which means to only run on mount and unmount. Let's see how we're going to make use of that. I've created a random joke component inside of our containers folder, and we start off by importing a couple of things that we're going to need. Firstly, a styled component called joke container, which is actually just a wrapper that is going to provide some padding to our joke, which will live right above the to-do list that we're going to be creating. In addition to that, I've got an API request function that is part of our helpers list of functions that I created earlier. And inside our actual component, I'm going to be making use of the useState hook for state values, joke, and loading, as well as functions to update these respective values. And now, this is where we're actually going to be implementing the useEffect hook. And so, remember I mentioned that it takes two parameters, a function, and after that, in this particular case, I'm going to be putting an empty array. And the reason I'm putting an empty array is because I only want to make the API request once when the component mounts. And that's why I'm actually doing that. And inside our function, I've got a definition over here called getRandomJoke, which is just making an API request to this particular API, which just gets a random joke. And in the case that the request is still being made or still being processed, then loading is going to be set to true. And when that has actually been completed, it's going to be set to false. And we want to update the joke state value based on the joke that actually gets returned. So what can we expect back from this particular component? Well, in the case that our request is still loading, then we're just going to return this string that says, "Why so serious? Let's put a smile on your face." And if that has actually been completed, then loading will be set to false and we'll return the joke. That now leaves us with the two remaining hooks that we're going to be exploring, which will both be dealing around our actual to-do list. Let's take a look at that. When you work with class-based components, you can use references to interact with the DOM elements on the page. Before hooks, this is something that you couldn't do because function components didn't have properties that you could use to store any of the references. Now we can, thanks to hooks, and obviously in this particular case, the useRef hook. And so what we're going to be doing is I'm going to create a component called addToDo, As I mentioned previously, we're now turning our attention to the actual to-do list. And so in this add to-do component, I'm going to create a reference by storing it in a constant called text input. You can name it something else if you like. And you can optionally set an initial value for this reference. I'm going to set it as null. And so the reference to the input field is stored inside the constant once we actually add text input to the ref prop in an input JSX element. So this is much easier to understand when we actually interact with the code. So let's take a look at that. Here we are in our add to do component that I just mentioned, and it's also listed inside of our containers. And this component returns a form, and this form will have a single input field for the user to enter the to-do item, and there'll be a button that they can click on to submit that to-do item to have it added to the list. And we are importing the error message component just so we have it displayed in the case that a user tries to enter or submit the form without any text that was entered into the input field. In addition to that, we're making use of an input styled component that was one of the initial styles that we added right at the start. And lastly, another input over here is the custom hook that we created for handling error logic. Now, previously when we worked with a form, on the sign-in page, we were using the useState hook to track the value for the input field. This time around, we are using the useRef hook. And so we're going to be using the internal state management of the input element and using a ref to extract its current value whenever we need it. And so when this form gets submitted, a user clicks on add, and the add new to do item function is executed. We simply do a check over here using our ref to try and view the current property to ensure that it is not falsy or that it is not undefined at this particular point in time. And in the case that a user has actually entered some text, then we'll be able to extract that value. And for now, I've simply put console log. We're going to actually add some additional logic to this when we're working with our useReducer, so you don't have to worry about that right now. But in the case that a user submitted the form and didn't enter anything in the input field, we're going to throw an error using the custom hook that we created. Right, so for now, this is actually incomplete because there are a couple of things we're going to add to this while we explore the useReducer hook, and we're also going to add an additional context. So let's move on to that now. Finally, we come to the useReducer hook. If you're familiar with Redux, then you probably know what a reducer is. But if it's the first time that you're hearing about it, that's totally cool. Not to worry, I'm going to explain it. A reducer is a function that helps us to manage application state. It's a pure function in the sense that it always returns the exact same output given a certain input. In the case of reducer functions, it takes two arguments or parameters, the current state and an action. The action is an object with a type property, and based on that action type, the reducer performs a certain state transition. As usual, a lot of these things make a lot more sense when you actually see how they play out. So let's look at it. I'll be implementing it inside of the to-do context, which is the second context we'll be making use of in our application. I should mention that there are a couple of pieces that I haven't necessarily demonstrated because they're not imperative for what we're trying to achieve in here. And those blanks can be filled in if you definitely take the time to check out the post that I released on Medium, as well as the associated repository, and it'll help tie up some loose ends. So I start by importing an enum action type over here, just so we know the different types of actions that can actually be carried out in order for a state transition to take place. And then I've got three interfaces that I'm defining. The first one is for our state value, which is going to be a to-do list array, and that array obviously consists of to-do items, and each item will be an object that has this particular shape. Next, we've got an interface for the shape of the object that will be passing through to our dispatch method. Now, the dispatch method receives this object, which represents the action we desire to be done. And we ultimately pass our action to our reducer through the useReducer hook, and our reducer will then return the updated state. The third interface over here defines the shape of our context. Now, in our context, we want to be able to provide different components with the actual state value, which will be our to-do list array, as well as a function that allows us to update this particular state. And so that will be our dispatch method, which starts this process of transitioning our state. And I'm not calling mine dispatch, I'm calling it update to-do list, but you'll see here that it has a type of react.dispatch. I then go ahead and set the initial state. This is going to be one of the parameters that we'll have to pass through to the useReducer hook. And the initial state is just an object with an empty to-do list array. Next up, we actually have our reducer function over here, which is a pure function. And as I mentioned, it takes two parameters, the first one being the state, and the second is an action. Now, the action is an object, and that object will have a type property, and depending on the type, it will action a certain type of state transition. So we have add, we have update, and we have delete. Add will add to the array of to-do list items. Update will update a particular item as to whether or not it has been completed, and delete will obviously remove it from the array. In this case, we're only going to be making use of the add and the update. And when I come down here, I'm actually creating the context, and I export it over here so that any component that wants to be able to tap into the context and falls inside of that provider wrapper context component will be able to tap into this with the useContext hook. And then lastly, we come to the section where we actually export our provider. The to-do provider will be wrapped around our app component. And just like we did with Auth context, we pass a children prop so that any other component in our tree structure will be able to fit inside here. And what we want to be able to provide to our application is the to-do list as well as the functionality to be able to update that particular to-do list. So we're using the useReducer hook over here, and I should mention that reducers are really helpful when it comes to managing complex state logic. And our useReducer hook takes two parameters, the first one being the reducer function that we created earlier, and the second one being the initial state, which is the object with an empty to-do list array. And as we have done before, we're using the destructuring assignment to get an array with two elements, and the first one being the to-do list array, and the second one being the dispatch method, but we're calling it update to-do list. And so I'm going to skip right to the end and bring us to our root container. And in the root container, you would actually tap into the auth context, and based on the auth object, you would determine whether or not a user is authenticated. And if they are, then you would go ahead and display the to-do component. And if they aren't, then you can display the login component. I've implemented this in the repository so you can check out to see what that looks like. But we're going to go ahead and head straight to see what our to-do list looks like in the browser. As expected, we get the random joke, and it's a Chuck Norris joke. I'm going to go ahead and add an item to our to-do list. Let's say eat, sleep, code, repeat. So it successfully populates our to-do list, and it also updates an item as complete or incomplete. And that's it.